Hello, today we are going to talk about inverse trigonometry in the principal branches. Our objective today is to use the principal branch of trig functions to find the one solution of the inverse trig function with no calculator today. Alright, so let's look at this first function. We have 6 cosine of 2 theta plus 5 equals 2. We want to find all the solutions. So what we have done already in the past is we solved this algebraically. And let's just review this. Some of you may be able to stop and give me the answers before I do. That would be good practice. So I subtract the 5. I divide by the 6. I get cosine of 2 theta equals negative 1/2. Okay? In the old lesson, we ask ourselves, where's cosine negative? That puts me in the second quadrant and in the third quadrant. And you ask yourself which angle, when you take cosine of it, gives you 1/2. Your reference angle is going to be 60. So our two answers here are 120 degrees and 240 degrees. So now though, instead of it just being those are our answers, that's what 2 theta equals. So I have 2 theta equals 120, and I have 2 theta equals 240. Now keep in mind, that's just one time around the circle. So if you want all solutions, you have to add plus 360n to both answers. All right, and then you do algebra. So from here, I just divide everything by 2. Okay, and the top part gives me theta equals 60 plus 180 n. So if I pick values for n equals 0, my answer is going to be 60. If n equals 1, my answer is going to be 240. If I pick n is 2, now I'm past 360. Okay, so then I look at the second one. I'm going to have theta gives me 240 divided by 2, which is 120, plus 180n. Pick the same values for n, so n is 0, I'm going to be looking at 120. And if I pick 8, I'm going to be looking at 300. So I have 4 solutions for this graph. And if we look at it graphically, you can see my 4 solutions would be where this graph actually equals 2. And you can see one intersection already is 300. So this would be the 240, this would be the 120, and this would be the 60. So kind of a graphical way to go along with the algebra we just did to come up with our 4 solutions. And if I'm being great, I should really put degrees on all of these. All right, so now we're going to take a look at the domain and range. I've talked about this a little bit. The domain is all the x values or all the theta values that this function can take on. And so we know that theta, because the graph for sine just goes on forever in both directions, right? So the domain is negative infinity to infinity, or all real numbers. But the range are, what are the y values? And so the y values are contained between negative 1 and 1. So when you're asked to figure out sine theta equals 1/2, how many answers do you have? You have infinitely many. Right? Because it goes on forever. But if I switch it around and now only want to look at the inverse sign, remember when we do inverses, we just flop that x and y's around. So you keep that same idea. So you know that x is usually your domain, right? These are our x values, or in this case our theta values, and these are our y values. So if you're going to do the inverse, you basically just flip that. So now our domain is going to be negative 1 to 1. And our range is going to be negative infinity to infinity. But this creates a bit of a problem. So we are going to have to adjust this. because if you flip the sine curve, it does not pass the vertical line test. And so therefore, it's not a one-to-one function. So we're going to have to mess with this range in a little bit. So let's just do some investigation. So in our calculators, let's figure out what values we have for inverse sine of 0.1. So in your calculators, just do inverse sine of 0.1 and go through there and get an answer. My calculator's in radians, so I should probably put it in degrees. So over here, because in this case we're in degrees. So now I get 5.39. And you go through and do that for the whole positive decimals, and I just plug those in. And so those are the numbers I got for inverse sine of all those. And you can see, you know, we're starting 5, 17, 30, 53. Okay, if I look at doing negative values, so if I do negative 0.1, notice the answer is close to the same, only they're opposite by a sign. So, okay, and remember these are angles, all right? So if you're thinking about these being angles, these are all in the first quadrant. These guys are all in the fourth quadrant because they're all negative angles. So this actually helps us determine our range because we only have angles in the first quadrant and in the fourth quadrant. So we say our range is from negative 90 to positive 90. All right, let's take a look at it graphically. So we know this is sine. The sine graph is the first one graphed. And if we looked at the domain, generally if we look from negative 90 to 90, we're grabbing a quadrant where sine is negative and a quadrant where sine is positive. Because again, if you think about flipping this, switching it around, it's not going to pass, it's not going to be a function. So what we need to do is we need to make sure that we stop it so that it is a function. So we are only going to pick from negative 90 degrees to positive 90 degrees, and that is now my functions where I'm going to stop my function. So you can see this graph down here, this is inverse sine. And then we just figured out our domain is from negative 1 to 1, and our range is going to go from negative 90 to 90, or for in radians, negative pi halves to pi halves. All right, let's investigate cosine. Okay, so again, the domain is the ratio of the sides, right? So side lengths, and the range are our angles. So if I put these into my calculator, which I have already done, I'm going to have these for decimals. So 0.1 is 84, 0.3, so we're getting less the closer we get to 1. Okay, so again, keep in mind that these are the angles. And this is the adjacent side divided by the hypotenuse. All right, if I switch now and go negative ratios, I end up with these for answers. All right, so you might want to think, okay, how do these numbers relate to each other? So if you look at them, 84.264, 95.739, the easiest one to see is 60 and 120. They should all add to be 180 degrees. Okay, these guys are in our first quadrant, and these guys are in our second quadrant. So in our domain, we know that the ratios of our sides have to be between negative 1 and 1 again. And our range of our angles kind of look to be like they're going from the first quadrant to the second quadrant. Okay, let's look at it a little bit graphically so we can see that. Again, you can see here's the cosine curve. If I am to, kind of flip it not quite right, but if you flip it, you can see that this function would not have a inverse function because it doesn't pass the horizontal line test, right? It's one way to tell it fails the horizontal line test, so therefore it's not one-to-one or invertible as a word we've used in the past. And so we have to restrict it. So what we do is we say, okay, well, I'm going to find a quadrant where cosine is positive and a quadrant where cosine is negative, because then that will take on all the values this graph ever had. And so we break it up from 0 degrees, so right here, to 180 degrees, and that becomes our principal branch. And again, if we're working in radians, the range is 0 to pi instead of 0 to 180. And this is what I graph inverse cosine. All right, last trig function we're going to talk about is inverse tangent. Okay, so again, if you think about inverse tangent, it's quite different than the other two. If you think about the ratio sides, really, if you look at the tangent graph, and sometimes it's actually more helpful to look at the tangent graph, it went from positive, right? So if I look at just tangent of theta equals y, you had values where you had problems. Remember, you would have undefined. Again, think about the slope. It was undefined where you had a vertical line. So there were restrictions to tangent's domain. So this time there are going to be restrictions to tangent's range. Okay, but the y values went to positive and negative infinity. So now if you're doing inverse, you switch. So the domain is going to be from positive to negative infinity or negative infinity to positive infinity. And the range of the angles we're going to have to mess with a little bit. Okay, so you can kind of see, if you look at the tangent, and I'll look at the next slide. Again, this is not one-to-one or invertible because it doesn't pass the horizontal line test. But you can make it pass the horizontal line test pretty easily if you just look at one little tangent graph. And so that you can again see you want one area where tangent is positive, one area where tangent is negative. And so you are going to be just like you were in sine from negative 90 to 90 or negative pi halves to pi halves. The first quadrant is always there for all of them, and then you want the one adjacent to it that gives the opposite sign. So sine and cosine, sine and tangent would both be the first and the fourth, but cosine was the one where it was the first and the second quadrant. So that's the odd man out in this case. And so if you look, this is what I graphed in my calculator for inverse tangent. And so you can kind of see the domain goes forever, right? This graph continues positive, negative infinity. But the range looks like it has now some horizontal asymptotes, which it does. And those happen to be at negative 90 and 90 degrees.